We are official. Okay. So what you have learned the last few days on simplifying rational expressions is the foundation to all the harder stuff. And that's where we're moving into, the harder stuff, okay? With rational expression. So we're going to talk about adding and subtracting rational expressions today. And probably tomorrow, we'll probably be talking about multiplying rational expressions or dividing rational expressions. So today is just adding and subtracting. But the key with adding and subtracting is, well, one, that we are dealing with fractions, ratios, fractions, right? And because we are dealing with fractions, whenever you add and subtract a fraction, you have to have common denominators, right? So that is the key to all of this. Is you got it. Number one, you have to have common denominators. Once you get your final answer, it's not final yet. You actually have to simplify it like you did last night and the night before and whatever. All that simplifying is part of this, and also stating the excluded value is part of it. Okay. Very simply, what if I had x over x plus 3 plus x over x plus 3. All right. First of all, do I have common denominators?
Yeah.
Yes.
I believe
So what does that mean? What can I do to the numerators? I'm sorry, I can add them, right? So what's x plus x? That's x times x. That's
2x.
X plus
2x, right? So it's 2x over x plus 3. All right, so now that I have gotten my answer, I now have to see if I can simplify it, okay? That's really critical. Number one, you got to make sure you have common denominators. Once you once you do, you put that common denominator in your answer. You add your numerators, and then you ask yourself, can I simplify this further? And the way to know that is you ask yourself, first of all, can I factor anything out of the numerator? Can I factor anything out of the denominator? No, I can't, really. 2x, there's nothing else. It's just 2 times x, 2x, right? This, x plus 3, I can't factor anything out of that. Now, what about up and down? Does 2 go into x? Does 2 go into 3? Does x go into x? Does x go into 3? X goes into x, but because this is a plus sign, it's a binomial, I can't do anything, right? If it was x times 3, then yeah, I could take the x's out. But it's x plus 3. Therefore, I've got to take this as a total blob, right? I can't take anything out of this blob unless it's the same blob upstairs. So I'm done, except that I have to say, what is my excluded value? So I go back here. Look, this is they're the same numbers here, right? So what is, actually pretty much when you're adding, I think all you have to do is use your common denominator. So this is your common denominator. What can x not be? Negative 3, right? You can't have, if x were negative 3, it would be 0 in the denominator. It would be undefined. So x cannot equal negative 3. And that's my answer. Pretty straightforward, right? That one's pretty easy, right? Everybody? Yeah. All right, how about this one? How about like x over x plus 6 plus 6 over x plus 6. All right. Again, we have common denominators already, right? So I can put that common denominator in my answer, x plus 6. Now what do I do to the numerator?
Add it.
Which is?
7x. X plus 6. 6x plus 6.
It's x plus 6. It's not 6x. It's x plus 6. See the difference? They're not the same thing. So you have to keep it like x plus 6. All right, so I'm basically done. I've done my adding. I've gotten my final thing. But now I have to ask myself, is there anything I can do to simplify it?
Possibly.
Right. They're both the same thing. So they come out as a 1, which is 1. Now, I still have to say, what can x not be? What's the excluded value?
Negative 6.
Yeah, x cannot equal negative 6. And that's my answer. All right? Pretty straightforward. What if I gave you, okay, let's see, how do I do that? Okay, how about this one? So this was 1, this is 2, here's 3. What if I gave you this? X, let's see here. Okay, so here we go. X over 4x squared plus 7x over 4x squared. So I have common denominators, right? Yep. Okay. So I'm going to write my denominator down there. John, make sure you're writing these all down. There. All 3 of those need to be written down. I'm doing this so that you guys will have no trouble with homework. If you write these down,
but I know this.
I'm specifically, I don't care, write it down. Guys, get in the habit always, just so you guys know, I know most of you are doing this fine, but I just have to say, if you want to know how to pass a class in college or high school, write everything the teacher writes on the board down in your notes, absolutely everything. Because if you want to know what the teacher thinks is important, I guarantee you it'll be on his board. There's a lot of stuff that he won't think is that important in the book. But what he writes on the board is really important. So always get in that habit. Write everything the teacher writes on the board. I took a class once at Santa Fe Community College. It was a physics class. And I wrote down everything he wrote on the board. He had a book too, and yeah, I read the book and stuff, but I didn't really spend, whenever we had tests, I didn't look at the book at all. I just looked at, I reviewed his notes, and I did all the problems again. I would write down every problem in my notes. I'd write it on another piece of paper, and I'd solve it and see if I got it right. And I aced that class. I mean, I got like a 98 in the class. And half the people failed the class. And it was only because they didn't take notes. They didn't do this. They just were trying to use the book. What the teacher puts on the board is gold. All right, so same square. It already has the common denominator. So what's x plus 7x? Hello? 8x. All right, so good. We're there. Now we have to ask ourselves, is there anything we can do further? Yeah, so what? What? Yeah, so the 4 can go into 4 once, 4 goes into 8 twice. Now what about x and x squared? There's only one x here, and there's 2 x's here, right? I could bring this down and take it away, take one of them away. So really I'm going to have 2 over x. You see that? You guys all remember how to do that, I hope, right? Okay, what can x not be? What? What?
0.
0. Yeah, sorry, you guys are talking so softly. X cannot equal 0, right? Because if it was negative 4, it would be a number, right? It might be negative. Well, no, it would be positive. It's got to be 0. The only way you can get some 2 numbers times each other to equal 0 is one of them has to be 0. 4 is definitely not 0, so therefore the x has to be 0. All right, so that's your answer to that one. Okay, so then 4. We're gradually going to get a little harder, so you guys can see these. All right, so now let's say we have 2. Oh wait, I can't do this one. Let me do it. 2 over 3x. That's fine. Plus 3 over 2 over 3x squared plus 12x. Okay. Plus 3 over 12x, sorry. All right, do I have common denominators?
No.
No. So what would be the lowest common denominator? Just for the number first. Just for the number first of all.
3.
Can you turn the 12 into a 3? If you had 1/3 plus 1/12.
Divide it by 2.
Yeah. No, but remember, think 1/3 plus 1/12. What would you do? Well, you would make the 3 into a 12, right? So you'd multiply top and bottom by 4, right? So then you'd have 4/12 plus 1/12 is equal to 5/12. We're going to do the same thing here. So we have a 12, we have a 3. We're going to turn that 3 into a 12. So we are going to, I'm going to use a different color just to make it easier to see. We're going to multiply this times 4 and this times 4. Okay, so basically times 4 over 4. I like to do it like this. And then, now that's going to give me 12x squared. You guys with me? But look over here. I only have 12x here. So what am I going to have to do on this side? If I multiply this side times x, I would get 12x squared, right? So I'm going to have to multiply this side by x over x. Always it's the same thing, numerator and denominator. So once I do that, I have 8, let's see, I'll do it here. 8 over 12x squared plus 3x over 12x squared. Now I have common denominators. So I can put 12x squared in the denominator. And then I have 3x plus 8. I like to write the x first, because that's a little more officially correct. It wasn't too hard. That wasn't too hard, right? You guys all understand how you do that? Yes? Okay. Now, what can x not be here?
0.
0. Exactly. X cannot equal 0. That's it. That's your answer. Oh, you also have to check and see if you can simplify. And there really isn't anything I can do. I can't factor out the numerator. I can't factor the denominator. So that's it. All right, I'm going to erase. Can I erase everything?
Erase the first 3.
First 3, okay. I'm trying to give you lots of examples because people get kind of hung up on these sometimes. All right. All right. How about if I gave you this? 3, 4, 5. Let's see here. Okay. So write that one down. X over x squared minus 36 plus 6 over x squared minus 36. Okay? I have common denominators, is that correct? Yes? Yeah. So I'm going to put an equal sign. I'm going to put my common denominator down there, x squared minus 36. And I'm going to add my numerators, which is x plus 6. Right? X plus 6. Now I have to ask myself, can I factor anything? I have to simplify first. If there's ever anything that can be factored, I have to do it. Because I won't know if I can simplify things without factoring. So I'm going to put an equal sign because I notice x squared minus 36 is x plus 6 times x minus 6, right? Yes. So parentheses x plus 6, that's the difference of two squares, times x minus 6, all over x plus 6. I mean under x plus 6. Right? Now that I have simplified and factored, well actually now that I've factored, now I can simplify. So what can I do? It's in both the top and bottom.
That's an arrow.
Right. So those can get crossed out. So I have 1 over x minus 6. Right? So I have to say, though, that x cannot equal, what is it?
6 or negative 6.
Yeah, because you don't stop here. You don't look here. You go back to where you factored the denominator, which was x plus 6 times x minus 6. If x were negative 6, this would be 0. If x were positive 6, this would be 0. So x cannot equal plus or minus 6. So that's my answer. All right? Is that clear? You guys with me? Is it making sense to you? Okay, 6. 6, 6, 6. Okay, we'll do another one like that, just because I want to see. Let's see. I gotta make sure I don't give you one to sign here. Okay. Actually, I'm going to do minus. Minus 18 over x squared minus 84. Okay. Write that one down. So 2x over x squared minus 81 minus 18 over over x squared minus 81. So do I have common denominators? Great. So I will go ahead and put that on the bottom, x squared minus 81. And then upstairs I have 2x minus 18, right? 2x minus 18. 2x minus 18. All right. So basically I've gotten my answer, but I have to simplify it now, right? So can I factor the numerator?
Yes.
Okay, what would it be?
2 times x minus 9.
X minus 9. Okay, can I factor the denominator?
Yeah.
What would that be?
Plus 9 x minus 9.
Right? X plus 9, difference of two squares. X plus 9 times x minus 9. Okay, good. Now, can I cross anything out now that I factored them?
Yes.
The x minus 9s, right? Right? So that gives me 2 over x plus 9. All right. That's my answer. Now I have to say the excluded value. So I go back to this, not just this, but this. If x can't be negative 9, or x can't be positive 9, right? So x cannot equal plus or minus 9. And that's my answer. Is that making sense? All right. 6, 7. These are a lot of examples, but you know they show up in different ways. So I want to. There's a lot of. I just want to be sure that you don't get stuck on some of these. What if I did this? Whoops, wait a minute. Not 2 over 2. Sorry. 2 over x plus okay. So write that one down. 2 over x plus 3 over x parentheses x plus 4. So what is my lowest common denominator? How would I turn x plus 4 into x? You're always wanting, it's always going to be the bigger one actually is going to be, the bigger one that's inclusive of the littler one is the one that's going to be your lowest common denominator. Right? So John, can you turn this into x, or can you turn this into x times x plus 4? Which would be easier for you to do? Would it be easier to turn this into an x, or turn this into x times x plus 4?
It's like you have to turn the other one into x times x plus 4.
Yes, exactly.
Hey, yeah, you got it right.
You never want to go. You never, like when you're doing regular fractions. You don't take the bigger number and divide it, right? You take the littler number and multiply it, right? So we're going to take the littler number, and we're going to multiply it by x plus 4, x plus 4. Okay? You with me? Now this time I have to use distributive property. Boom and boom. So that's going to give me 2x plus 8 over x times x plus 4. Now some people might say, oh, I'm going to just multiply this out to make that x squared plus 4x. Not a good idea. Because remember, to simplify, you have to have it factored first, right? We haven't simplified yet. We're just adding. So whenever you can simplify, do it. Whenever you can keep it factored, keep it factored. Now, upstairs, we're going to find that, look, now we can factor the upstairs. So I've got 2 parentheses x plus 4 over x times x plus 4. Right? So now what could I do? Cross out the x plus 4s, right? So that equals 2 over x. X cannot equal. What can x not equal?
Negative 4.
Negative 4, what else?
And 0.
And 0. Right? Either x, to make this time equal to 0, either x would have to be 0 or x plus 4 would have to be 0. So x cannot equal 0 or negative 4. So that's my answer on that one. Now notice I was kind of nice to you. I gave it to you in factored form. But sometimes you won't see that. Sometimes you won't see that. So you'll have to actually factor first. So what if I did this? 5 over x plus 4 over x squared plus 2x. Yeah.
What
Why?
happened to the 3 over x?
Yeah, you added that to the...
What did I do?
You simplified it and you never added 3 over x. Yeah.
Oh, yeah. Sorry. Oh my God, you guys, I failed.
Yeah, let's just act like it wasn't there.
Does he get that?
All right, so we have to add the 3. We had 8 plus 3, 8, 9, 10, 11. Oh, so we can't. I screwed up, guys.
Yeah, you did.
Yay, big time. Okay. All right. So that's my answer. This is the correct
Can't
answer.
see anything. Oh, plus 11.
And then we said x cannot equal 0 or negative 4. Thank you for catching that, Lila. Appreciate that. All right, now let's look at this one. Sorry about that, guys. Thank God for pencils and erasers. So now, what about this one? I wasn't so nice to you this time. I didn't write this in factored form, this denominator. I don't know how to turn x into x squared plus 2x unless I factor x squared plus 2x, right? So if I factored x plus 2x, sometimes I'll just put it underneath. Instead of rewriting the whole thing just to factor it, I'll just do this, x parenthesis x plus 2. Oh, that makes it so much easier for me to see what I have to do to this, right? This is x times x plus 2. This needs to be x times x plus 2. So I'm going to multiply this by x plus 2 over x plus 2. Which means I have 5x, distributive property, plus 10, plus 4, all over x times x plus 2. Doesn't. It's worse and worse. Okay? So, we'll simplify the numerator first. 5x plus 14 all over x times x plus 2, which is equal to, oh, well, that's what it's equal to. There's nothing else I can do. I can't factor the numerator, right? The denominator is already factored. What can x not equal? 0 or negative 2. X cannot equal 0 or negative 2. Great. All right. So let me know when I can erase the board, because I need to erase it. We just have a few more examples. We're just a little. We're going to go a little harder. Now that you guys have this down, can I erase? John, did you get that last one? Number 8.
Oh, number 8 now.
Well, read it off of Jason's, okay? Because I'm going to erase.
Yeah, read it off.
Sometimes there's so many different ways you'll see these kind of problems. That's why I'm giving you lots of examples. 9. All right. All right. So make sure you write this one down. Okay. So, do I have common denominators?
Yeah.
So I can immediately put an equal sign, and I can put my fraction line, I'll do an x plus 5 on the bottom. Now I have to add my numerators, okay? So I have this is the only x squared I have, so I'll write that first. I always want to put it in order of x squared, and then something x, and then something without an x, right? Now I've got my 4x plus 8x. What's that? So plus 12x. And then I have my 30 plus 5 plus 35. All right, so now I've gotten my answer. But now I have to ask, can I factor anything? Well, I can't factor the x plus 5, but could I factor that? What would it be? Factors of 35 that add to 12. Okay, so we've got x plus 7 times x plus 5. Let's just double check. 5x plus 7x is 12x. Outside plus inside. Yes, that's it. All over x plus 5. So, and what can I do now? Cross out the x plus 5. So really, my answer is x plus 7. That huge nightmare right there, all that boils down to is x plus 7. Now, what can x not equal?
Negative 5.
Right. Good job. All right.
Theory?
Yeah.
Isn't it like every time it's just like the denominator? Like,
Yeah.
yeah.
Can you like make it so that there's the denominator?
Can I make it say what?
Like,
Who's talking? I can't.
it's like every single time it's like on like the denominator, it's like x plus 5, and so x doesn't equal negative 5. Like.
Ah, right. So you're saying for the excluded value, you're saying? Yeah, it's always going to be the opposite of this. And sometimes you'll have more than one. Like I think, didn't we have one where we've had several where there were two possibilities. X could not equal 0 or could not equal. Yeah. So it's always going to be the opposite of that, right? The only thing is, what if it's 2x plus 5?
Then we're all doomed.
Then it would be negative. See, if it was, let's say the denominator was 2x plus 5, right? If that were the case, then think about it. 2x plus 5, if that equals 0, that would be 2x is equal to negative 5. Divide by 2, x is equal to negative 5 halves. So then x would not be able to, you see what I'm saying?
Yeah.
So if they're just plain like that, they're really easy. X is negative 5. But if they're 2x plus 5, then, you know, then you just have to do a little extra work there, right? And 10, let's see. All right, here we go, 10. X plus 3 over, all right, two more, just this one and one more and we're done. 4x squared minus 25 minus negative x plus 8 over 4x squared minus 25.
No, but seriously, like it's
All right. Do I have common denominators? Yeah.
Yes.
You're not always going to have common denominators, but you do. Here. Okay. We've got, so I'll put my common denominator, 4x squared minus 25. And then upstairs, this is where people are going to make mistakes. You see how it says minus here?
It's a minus and minus.
And then you've got a minus here and you've got a plus here. This is really minus 1 times all of this. So really, all of these signs, because of this minus sign, will change. Minus x becomes plus x. Minus 8 it becomes minus 8. Plus 8 becomes minus 8. You see why? See what I mean? Okay. So we've got upstairs we have x plus 3. I'm going to write it like this. X plus 3 plus x minus 8. So I'm going to rewrite that. So I've got 2 x's. And then I have minus 2x minus
5.
right, minus 5, right? Jeez. Brain fart. Okay, so, whoops. Oops. Sorry. This is a video lecture, thank you. Okay, this is, what is that one going to be?
2x minus 5, x plus 5.
Difference of two perfect squares, right? Difference of two perfect squares. Okay. And then I can cross these things out, right? Those cross out. So it equals 1 over 2x plus 5.
Yeah.
X cannot equal. Okay, this is where I go to. So Tiana, this is an example right here of how they're going to be a little different. So 2x minus 5, if that equals 0, I'm doing this one first, and I'm going to do this one. 2x plus 5 equals 0. John.
Yeah.
Who's talking?
Sorry.
Oh, okay.
No, don't blame me for everything.
Sorry, I thought it was you. Sorry.
It's okay.
Plus 5, plus 5. We've got 2x is equal to 5. X is equal to 5 halves. So x cannot equal 5 halves. Let's just see. This is going to be negative 5 halves, right? Where x cannot equal negative 5 halves. So it'll be plus or minus 5 halves. Let me just look at really quick at the homework. Okay, yeah. So just one more example.
One more minute.
One more example, really fast. If I had 11, I know this was a hard class, guys. I'm sorry. But we'll keep it simple. 2 over x plus 2 plus 3 over x plus 3. Is this on the homework? I hope not. Wait. Just quickly look at. Keep it quiet for a second.
Silence.
What's my lowest common denominator going to be?
1.
No.
What?
X plus 6.
It's this times this. This times this. Right? So I'm going to have to multiply this by x plus 3 over x plus 3. And you're going to have to FOIL here. And this is going to have to be x plus 2 over x plus 2. Right? And John, get this? You're going to have to FOIL these, right? These are going to have to be FOILed. First, outside, inside, last. Does that make sense?
Yeah.
You'll have to multiply. Actually, wait, what am I saying? No, you don't have to FOIL these. What am I saying? No.
I don't know.
Sorry. I'm sorry. I'm in a hurry. You don't have to FOIL them because you want them factored. You keep it factored. The only thing you have to do is distribute a property for the numerator, add them together, and whatever. You're done. Okay, that's it.
Bye,